In this section, I'd like to demonstrate on how to access the generated lifecycle profile objects by standard SQL. Let's switch to the already created lifecycle profiles. Query on, check the first lifecycle profile and check on the rule editor settings. The last setting was to displace data relevant for Cal year 2011. So this is the data set being active in the dynamic tiering data, and the remaining data set still sits in the source persistency. If you switch to destination persistency, you'll find the persistent objects like the dynamic tiering table specified in this schema. This is the table name, and also the pruning node to access the full data set. Let's switch to HANA Studio, where I'm connected to the DD4 database tenant relevant for our demo. Let's start to count the number of records in our source table. And execute. The number of remaining records in the source table is close to 7 million. And also select the number of records available and displaced to the dynamic tiering table. As listed before, the table is accessible in the schema, and the table name has been derived from the DLM profile. Let's run it. The number of records let's specify the number of records displaced and available in the dynamic tiering table. The dynamic tiering table has been created in the schema. The table is available within the table section. This is the number of records being displaced, so the total need to be specified right now. Let's use the generated pruning node to query the complete data set. The generated pruning node is available within the same schema within the column view section. And as we want to find out, based on the latest rule editor setting, how many records are available in dynamic tiering by querying the pruning node, we can apply the filter according to the rule editor setting. Latest setting was calendar year equals 2011. Let's query the pruning node. And the complete result set is being displayed. As we listed before, this is the exact same number we queried before on the dynamic tiering table. You can also apply any other type of filter, like if you want to query for calendar year 2010 and cal 1, 2 equals 3, which has been our initial setting for the data movement rule on the same lifecycle profile. You can take it and run it. Query returns exact the same amount of records we displaced initially when we set up the lifecycle profile. This record count is determined right now based out of the table in the hotstore table. As with the latest setting on the lifecycle profile, we only displays data relevant for calendar year 2011. With this selection, we're also querying the data within the hotstore table, and the dynamic pruning node logic will make sure that it analyzes the where class and only selects the data out of the hotstore table. The pruning node is specified to act as the integration or interface layer to your HANA application, as we provide the complete access to the full data set, and you can apply any filter you like, and the pruning node logic will make sure to optimize the access and prune the access to the only relevant data stores. If you want to further on create some virtual data models, you can simply use the generated pruning node and integrate the pruning node into a calculation view. To do so, scroll down to the content section within the user I'm working on right now. We have a package created. I'm going to create a new calculation view. Give it a name. The calc view editor starts up. Let's move up to the catalog section to identify the pruning node view. Mouse it over, and the number of available fields is being displayed. Let's select the objects as a subset relevant for our query. Apply the semantics. Check and activate. The calc view got successfully activated. If you now switch back to the query interface, we'd like to access the calculation view with the included DLM pruning node via an SQL statement. The generated and activated calc view is available within the SysBig schema. Let's mouse copy it over and apply the filter relevant for the current specification of the lifecycle profile. Let's execute the calculation view. And the result set is being displayed, which is the same number of records available in the dynamic tiering table. The same amount of records have been also accessed before when we were working on the current selection of the dynamic tiering table. So you can query any type of SQL on the generated and activated column view of the calculation view. Again, you can not only query on the generated pruning node view to access the full data set by giving any type of where class, which can already act as the integration and interface to your HANA application. You can also integrate the generated pruning node into a virtual data model, in this case a calculation view, which can be also further stacked with additional calculation views on top. The included pruning node will automatically optimize the access to the relevant data stores, so there's no additional effort required to optimize the access to the right data store, if that's going to be a HANA table, a dynamic tiering in our example, or some external sub-IQ database, or with a later HANA SPS 10 version the access to Hadoop via Spark interface. This concludes the section on how to access the DLM generated object using SQL, and it should also highlight the option to integrate the DLM generated objects into your HANA application. We still get the flexibility to adjust the data movement rules within your Data Lifecycle Manager section, but the interfaces to the outside to be integrated into HANA applications will stay stable, so there's no change to the generated HANA views, in this case, the pruning node view. And you get the option to keep your HANA application stable as DLM manages the underlying movement of the data without changes to the interface views. Thank you for watching this video.